Okay, so on day 4, we're going to continue our talk about factoring and expanding, really. And those are reverse processes. Processes, maybe? I'm not quite sure what the word. But I think this is probably a good description, products and factors. So over here on the left, we have factors. So if here's the equal sign right down the middle, over here we have factors, and over here we have products. I know it looks a little weird to call that product, but it's the result of multiplying two things together. That's what a product is, right? 16 is a product. It's the result of multiplying 2 times 8, or 4 times 4. So, we have to think of these quadratic expressions as products, and what we multiply together is 2 factors. So this is kind of like the guess and check game that we've been playing in the previous day, and so we know we we need to either set up a star, and we're going to really focus on the star today. That's going to be our preferred method. But the bottom line is we have to multiply to 1 times 12 in this first problem. Multiply to 1 times 12, which is 12. And we have to add, in this case, because it's a plus plus, we have to add 7. And so given our options, this one satisfies both, so that's what goes into the brackets, 3 and the 4, and since we have a coefficient of 1, we know it's just x and x. And then, of course, we can do our claw or our FOIL here and get 6x squared as our first terms, and then our outside terms looks like to be plus 8x, and then our inside terms look like they are minus 3x, and our last terms are minus 4, and then you could also do that square method that we did, the area model, and we're always looking to combine like terms, and those like terms are our outside-inside terms, and so we get that as our product. And we can go and fill in the blank, and I'll let you do that if you want some extra practice to fill in the blank. But here is kind of the meat and potatoes, so F and G. Okay, these are the ones we have to learn how to factor, and we don't have a we have a strategy. It's the star method, and I call it the advanced star. But if you notice, neither one of these we can't divide out a coefficient. The coefficient in front of the x squared term. So in other words, if we tried to divide out a 5 here, that wouldn't work because 21 and 18 are not divisible by 5. And likewise, if we tried to divide out a 4 here, that would not work because 11 is not divisible by 4. So those strategies don't work. So we have something that's called I call it the advanced star. A lot of people just call it the star method. And we've been setting ourselves up for using the advanced star even back in day 3. So let's take a look at that. What letter is that? Letter F. So we have a star here, and the top is always A times C. That will never change. A times C for this question is 5 times 18. 5 times 18 is, let's see, 5 times 8 is 40, carry the 4, that's 90. And then the bottom number is always B. So this is minus 21. So we know we have a plus minus. No, we don't. Excuse me. I was wrong about that. We have a positive product, and we have a negative B. So we have a minus minus situation going on there. And here's where the star takes a turn. In these upper sectors here, we are going to place the coefficient that we see, which is 5, with an x. And what that's saying is that we have the potential of having 5x in our bracket. Okay? And And then now we need the factors of 90. So scrolling back through your notes, 90 has a ton of factors. We've got 1 times 90, we've got 2 times 45, we've got 3 times 30, we've got, I don't think 4 goes into 90. Nope, I'm looking at the factor sheet. We've got 5 times 18, we've got 6 times 15, and we've got 9 times 10. And we have to make negative 21 by adding negatives. So this is the way we can make 21, 6 and 15. So minus 6 and minus 15 gets us a negative 21. And here's where, this is why I'm calling it the advanced star or the extended star. It's because, first of all, we have a 5x in those sectors. And second of all, we have a potential, obviously, maybe not obviously, but if we tried to make the brackets right now 5x minus 6 and 5x minus 15, that's not going to work because 5 times 5, if I do that first FOIL, is 25x squared. And we don't have a 25x squared in the problem. So that is not going to work, okay? So that's out of the picture. We have to reduce either one or both of these. So when we look at the coefficients here, 5 and 6, there's the only thing that goes into 5 that also goes into 6 is 1. So these are not able to be reduced. But 5 and 15, we can reduce by dividing out a 5. So we have an extra factor of 5 here because we just didn't know where the 5 should be. So we put it in both spots. So we're going to take it out of where it doesn't belong, which is the one on the right. And this reduces to 1x, and this reduces to negative 3. So in our brackets, then there's 5x minus 6 times 1x, or just x. Let's just call that x. X minus 3. So that's the factored quadratic. Okay, let's try this last one here. So I want to stay away from green. Let's go blue. So setting up this star, A times C. In fact, why don't you try to pause the video and do this on your own and check the work. So I'll give you a chance to do that. Okay, if you're coming back here, you are hopefully have tried this on your own. So this is 4 times 11, and that's a positive 44. And then we put a 4x in both of these spots. And then the bottom number B is plus 24. Okay, so looking at our factors of 44, we've got 1 times 44, 2 times 22, and 4 times 11. And we have to make 24. And these are all positives, so it's a plus plus because I have plus here and plus here. I have a positive product, so I know I need like signs, and I have a positive B. And this is the only way we can make 24 with positives. So 2 and 22. And again, now we have to get rid of, we can't have 4 in both brackets, right? So we know that we can't have 4x existing in both brackets. And in this situation, 4 and 22 can be reduced, and 4 and 2 can also be reduced. So we're going to do a double reduction here. So we're going to reduce on the right. So we're going to divide by 2. And we're going to end up with 2x and 11, and we're going to divide by 2 over here. So notice dividing by 2 gets us 2 times 2, right? This is also going to be 2x, and this is going to be 1. And so now we're going to have 2x plus 1 and 2x plus 11. And now when I expand that out, I'll get that product of 4x squared plus 24x plus 11. You can always check yourself by going through the foiling process. All right, we can always come back here and say 2x times 2x is 4x squared. 2x times 11 is 22x. 1 times 2x is 2x. Notice 2 and 22 are the factors that we picked. And then 1 times 11 is 11. So that checks, this checks with the original problem. Okay, so there are other ways of determining how to factor without using the stars. I just think it's a little convoluted. You really have to watch your numbers. I think the extended stars is really an excellent organizer in this situation. So our learning target 1 is our extended star. And so if we look at maybe number 4 here, 6x squared plus 11x minus 10. So an example would be, let's do the 6x squared minus 11x. Was that minus 11x? Yeah, no, it's plus 11x. Plus 11x minus 10. I'm just looking at my notes here. Let's do that example as an extended star. So we know, actually, let me move this over to here. I'll really kind of spell it out, so to speak. We know that A is 6, and B is 11, and C is negative 10. So A times C is 6 times negative 10. That's negative 60. We know we put a 6x in both locations, knowing that it can't possibly exist in both locations, but we just don't know where it's going to end up or if it's going to be changed. And then we have a negative 10 here. And then looking at our factor sheet, 60 has a fair amount of factors. So the factors of 60 are 1 and 60, 2 and 30, 3 and 20, 4 and 15, wow, 5 and 12, 6 and 10, and that's it. That's enough. Wow, that's a lot of factors. So now, observing here, we have a negative product, and the only way to get a negative product is to have signs that are mismatched. And then we have to make a negative 10. So we need two factors that when we subtract them, we get a negative 10. And so looking through these choices, I realized I made a mistake, right? This shouldn't be 10, it should be positive 11. If this was negative 10, this wouldn't work at all, right? And you notice this is where this is kind of a good opportunity for me to highlight how the star might break down. I forgot to put B down here, right? That's part of my organizer. I have A times C written here. That causes me to focus on these, and I did not write B here, and that made me get a little confused when I was referencing my coefficients. So it's kind of a good opportunity. My mistake is kind of paying off. Hopefully you don't fall into that pitfall. So this needs to be positive 11. Now, if we take 15 minus 4, that gets us positive 11. So that means 15 needs to be positive. And I'm just going to change this to orange. And 4 needs to be negative. There we go. And then I'm going to scooch this over a little bit more because I have some reducing to do. There we go. Okay, so now I got some space to reduce. Okay, so it looks like now I can reduce, I can take a 3 out of this side. So divide by 3, I get 2x. Divide by 3, I get positive 5. And I can take a 2 out of here. That gets me a 3x. And this gets me negative 2. And so I'm just checking here, right? 2x times 3x gets us 6x squared. So that was working out in my brackets. So my brackets then are 2x plus 5 and 3x minus 2. So there's your extended star learning target. don't fall into the pitfalls that I fell into, right? Make sure you do your A times C and your B here, so you set up your star correctly. If you want to do the check your understanding, you can. If you feel like you can jump right into the homework for 6-4, that's fine too.